Okay, guys. Hoping you have a great day. Sorry I'm not with you, but I am here virtually with you guys. So what I wanted to do today is talk about two keywords. The first one is the idea of domain. And the domain tells us all of the x values we are allowed to put into a function. Sometimes these values are called inputs. Think about what we just did with the function machine last week. We can look at it on a graph of a function or its equations to determine its domain. If we can have only the equations, sometimes it's easiest to ask what number can't be plugged into this. And we're going to deal with that later. But what we're going to look at today is we're going to be looking at graphs and tables to try to identify the domain. So when I'm looking at this, I'm trying to identify all the x values. So if you guys remember, this is my x-axis right here. And I want to identify all the x values that this graph exists for. So it looks like it starts here at -3 and it ends here at 3. Now, do all these other points have a graph? Like if I look at -2, I can see, hey, there's a point right there for -2, so I know it exists right there. At -1, there's a point right there, so it exists right there as well. 0, it exists at 2. When I look at 1, it exists here. When I look at 2, it exists right here. And all the points exist in between. So what I can see is anything between -3 and 3 exists for my graphs. What I can say is that all of my x values are between -3 and 3. And if you guys remember what we did on Friday, we talked about this compound inequality in which if x is in between -3 and 3, we can put less than or equal to symbols between them. Now let's look at the idea of range. Range in this case tells us all the values that come out of a function once we plug in and plug in x value. In other words, all the possible answers or all y values that exist. Okay? And I want to look at these two examples. So if I look here, if I look at this graph, and we're going to deal with graphs a lot today, but if I look here, it looks like there's no y value smaller than here. And then it looks like there's values that keep on going up, up, and up. If you guys notice, these arrows keep on pointing up, so that means they're going up forever and ever. Amen. So that means that y would have to be larger than or equal to 0. Now looking at these y values, it looks like it starts at 3 and then it goes down, straight down, because these y values keep on going down as well. So what do I know about all those? Well, y would have to be smaller than or equal to 3. All the y values are smaller than 3. But let's look at a table first. These are the easier ones. So let's identify first what the domain and range is of these ordered pairs or tables. So we're going to identify all the x values. What are all my x values here? That's an x, that's an x, that's an x, and that's an x. So 3, 7, 11, and 10 are my domain. The range are all the y values. So I got 5, -3, 9, and 8. That's the range, all the y values. Let's look at this next table right here. Oh, was this a function? Did each x have one y? Remember, that's what we talked about. It is a function. All right, let's look at this next one here. So I have -3. I got -2, -1, 4, 5, and 6 is all of my domain, all of my x. The range would be 8, 6, 7, 4, 5, and 3 would be the range. All the y values. Now, is this a function? Does each x have one y? Yes, so it's a function. I'm going to ask you guys to pause the video for a second and then try the next couple for me, and then I'll show you guys the answers. Okay. For number 3, I got that to be a function because each x had one y. This -3 had one y of 3 both times. So I got the domain to be -3, 0, 5, -8, 3, 5, -2, and 1 is the range, all the y values. And then looking here, all the x's, -3, -2, -1, 4, 5, and 6 is my domain. 8, 6, 7, 4, 5, 3 is my range, and it is a function. Hopefully this helps. We're going to jump into the next video in a second that deals with looking at graphs.